When you're factoring a difference of two squares, this is the pattern that you're looking for. You want a perfect square in these two places, and you need a minus sign in the middle because minus is what difference means. So when we talk about a perfect square, let's define that so you know what we mean. A perfect square is a number times itself. For example, 9 is a perfect square because that's 3 times 3. 25, that's a perfect square because it's 5 times 5. X squared is a perfect square because it's x times x. 64a squared is a perfect square because that's 8a times 8a. You always will have the same thing times the same thing. The same thing times the same thing. So once you have that pattern, this is how you factor it. Here's your rule. So you're going to do your double parentheses, and you're going to ask yourself, what do I square to get a squared, or that first spot right there? In this case, a times a. Then you're going to ask yourself, what do I square to get what's in that second spot? In our case, b squared, or b times b. Then your signs have to be a plus and a minus. All right, on this first one, I want to show you how you can check this. And I'll only do it the first time because I want you to understand why the pattern works. So if I was going to check this, I would take a plus b times a minus b. And then I would multiply or distribute. So a times a is a squared. A times negative b is negative ab. And then the b says, okay, my time, I'm going to distribute. B times a, when I multiply, is ba, or ab. And then I will say b times negative b, which is negative b squared. You'll notice that your negative ab and your positive ab cancel, and you're just left with a squared minus b squared, which is this right here. Now, I multiplied this or distributed, but you also might think of that as FOIL, to FOIL or multiply it out that way. All right, let's take a look at the first one. So I see that we fit our pattern, so let's do our double parentheses. This is a perfect square, and we ask ourselves, what do we multiply to get that, which is x and x. Right here, that's a perfect square, and that's 7 times 7, and you need a plus and you need a minus. The reason you need a plus and a minus also is because a positive times a negative has to give me a negative 49. I always put plus and minus, but you could do the minus and then the plus as long as you have one of each side. All right, let's take a look at example 2. It fits our pattern because these are perfect squares. So whatever do I square to get n squared is n times n. Whatever do I square to get 100m squared is 10m and 10m, because I need 10 times 10 to get 100 and m times m to get m squared. Then I need a plus and I need a minus. Example 3. In example 3, they put the number first and then the letter, and that's okay. You just have to do whatever they do. So I'm going to put whatever I square to get 144, and maybe you're familiar that that's 12 times 12. But if the numbers are ever too large and you're not sure, you can go to your calculator and just take the square root of the number, and it will tell you. And then x times x, and I need a plus and I need a minus. All right, let's look at example 4. In example 4, I can see that I have 6 times 6 to get my 36, so 6a and 6a. And this is definitely one that you might not be certain. So use your calculator, take the square root of 196, and you'll see that that's going to be 14. So 14 and 14, and then I need a plus, and I need a minus. Look at example 5. In example 5, as I look at this, it doesn't appear that it's perfect squares. However, if I look at this, I see that I can take out a greatest common factor. They both have a 2. So let's take a 2 out of each of those terms. And so 128 divided by 2 is 64, and then a squared, we didn't touch that, so we'll bring that down, minus 2 divides into 18 9 times. And now I notice I do have a difference of 2 squares. So sometimes you got to factor something out. So bring down your 2, then your double parentheses, and then to get 64, that's 8a times 8a. What do we square to get 9? Well, that's 3 and 3, and I need a plus, and I need a minus. Okay, look at example 6. In example 6, we can see again that 12 and 75 aren't perfect squares, but the fact that that's a c squared and a d squared, that's making me think that I probably do have a difference of 2 squares. So let's check for a greatest common factor again. Looking at your numbers of 12 and 75, I see that 3 goes into both of those. So I'm going to factor out a 3. 12 divided by 3 is 4. Bring down your c squared, minus 75 divided by 3 is 25, and then bring down your d squared. Now I can see that I do have a difference of 2 squares. So do your double parentheses. And if you'd like to, pause the video, try this one on your own, and then come back and check. So hopefully you said 2c and 2c, and you said 5d and 5d. And I need a plus, and I need a minus. All right, let's look at number 7. Looking at number 7, I'm trying to see if it's a difference of 2 squares, and it doesn't appear to be as is. But once again, if I will try to take out a greatest common factor, I might see that I actually do have a difference of 2 squares. So I know that a 5 will go into both of my numbers, and I actually see a letter. They both have an X. So my greatest common factor is a 5 and the letter X. So the 5 divided by the 5 is 1, so that's just like a cancel, a wash. You have 3 of these, take out 1 of these, and you're left with 2. Minus 5 divides into 80 16 times, and then I have an X, but I take that X out, so it's a cancel. Now I see I have a difference of 2 squares. All right, pause that video. Hopefully you said X and X. 4 and 4, and I need a plus, and I need a minus. Okay, let's look at example 8. Looking at example 8, it surely does not look like a difference of 2 squares. But if I will take out the greatest common factor, there's a possibility that I might have that. So taking out the greatest common factor, as far as the numbers are concerned, 2 is the only thing that they have in common. I see that they both have x's, and x to the first is what they have in common. And I see that they both have at least a y in common. So take out your greatest common factor. 98 divided by 2 is 49. You have x to the third, or 3 of them. You're going to factor out 1 of them, and you're left with 2. Your y, you're going to factor that out, so it's a cancel. Minus 2 goes into 50 25 times. Your x, you're taking out, so that's a wash, that's a cancel. Your y's, you have 3. You're taking out 1, so you're left with 2. And now it does fit the pattern of a difference of 2 squares. So bring down your 2xy, do your double parentheses, pause that video and try it on your own if you'd like, and come back and check. Okay, hopefully you said 7x and 7x because 7 times 7 is 49 and x times x is x squared. To get 25, that's a 5 times 5 and a y times y. I need a plus and I need a minus. These last two examples are double difference of squares. In a double difference of squares, you have to do it twice or double. All right, so it still fits the pattern of a difference of two squares. So I'm going to draw my parentheses. 9 times 9 is what I square 9 to get 81. Now x to the fourth, we usually see x squared, but this time we see x to the fourth. But x to the fourth is still a perfect square. That's x squared times x squared. And 1 is a perfect square. Sometimes students don't think about 1 being a square, but it is because it's the same thing times itself, 1 times 1. I need a plus and I need a minus. Now, on this next step, this one right here, we can't do anything because of that plus sign. You got to be a difference. Remember, a minus between two squares. Now, this we can do more, because that's a minus between squares. So on the one that we can't touch, we're just going to plop that down. But this is another difference of squares. So to get 9x squared, that's 3x times 3x. To get 1, that's 1 and 1. Now I need a plus and a minus. So that's what a double difference of squares looks like. All right, last one. And I see that we have a double difference of squares. So I'm going to do my parentheses. To get 16, that's 4 times 4, and a squared and a squared. You have to multiply to get 16. 4 times 4. Every once in a while I'll have a student say 8 and 8. But 8 plus 8 is 16. We want 4 times 4 to multiply to get that 16. Then for b to the fourth, that's b squared and b squared. I need a plus and I need a minus. This one, I can't do anything because that plus sign, so we're going to leave that one alone. But this one is a difference of two squares and we can do more. So bring this down just like it is. And then here, we have another difference of two squares. So we said that's like a double difference. All right, so that'd be 2a and 2a. That multiplies to get 4a squared. And b multiplies to get b squared. Then I need my plus and I need my minus. If you need more help on this topic, I have a teaching video that you could watch to get more examples. If this video was helpful, again, please like and subscribe to the channel. See you next time.